Hello everyone. The lesson today is about derivative rules. I would like to approach this topic in a simplified way by stating all the formulas to figure out derivative of our functions, and then we will see what type of function that we are dealing with, and then we will apply the correct formulas for that particular function. So before we get into explaining all of these rules, I would like to go over some terminology for derivative. So first of all, finding derivative of a function at a certain point is to find the slope of the line tangent to the function at that given point. The process of finding a derivative is called differentiation. So you probably hear this word throughout the entire lesson or throughout the entire unit. I probably will use the word to differentiate or to find the derivative or differentiation. There are quite a few notations for finding the derivatives. So you can present your derivative by f prime of x, dy over dx, y prime, or derivative of y as a function of x. So the notation that I will use throughout the entire unit is dy over dx. Because if you think about this notation right here, dy over dx representing the difference of y over the difference of x. So if you have the change in y divided by the change in x is representing the slope. Okay, so and all the formulas that I list up here for everyone, all the rules, is actually presented in terms of the d over dx as well. So let me explain the first basic rule of derivatives. The very first basic rule of the derivative is the d stands for differentiation. So this question basically asking you to differentiate a function c times x to the exponent n. Okay, the function of c times x to the exponent n, and you differentiate this in terms of x. So the rule for derivative is always like this. You get the exponent, you multiply by the coefficient in front of the x, and at the same time you take 1 away from the exponent. Okay, so the basic rule always apply. Okay, so take exponent, multiply by the coefficient. Immediately after that, you have to take 1 away from the exponent. So if you take derivative of a constant, then derivative of a constant is always equal to 0. Just like you take derivative, like derivative is the slope of the line, right? So if you talk about a straight line, okay, it means a constant. That means y is equal to certain value. Then in this case, what you have is the derivative of a straight line, or the line horizontal, or the line parallel to the x-axis, then the slope of that line is equal to 0. So in a way, the derivative of a constant is equal to 0. Derivative of a function raised to the power, and this one is called the chain rule. So most of the time, you will have a function raised to a power. So you know the difference between these formulas and these formulas right here. Right? So this formula right here, you have c times x to the exponent n, but in this case you have u raised to the exponent n, but you need to differentiate in terms of x. So therefore, the same basic rule apply, but you also have to apply the chain rule. Chain rule saying this. Okay, so take n, multiply by the coefficient in front of u, which is 1, and then you have n as a coefficient now, but then immediately after that, you must take 1 away from the exponent. Chain rule saying that you must take derivative of u and multiply by this. Alright, okay, so derivative of sum or difference of a differentiable function of x, then you have derivative of a function u plus function v plus function z, all of it as the interval of x, so you can differentiate each one individually. I will talk about product rule and quotient rule later on in the lesson because this rule is in fact a bit complicated. Before I get into the very basic rule of derivative and then we go over a few examples, I would like everyone to recall what we have done in previous lesson, okay, or in previous video. Before we get into derivative, I kind of ask everyone to work with this lesson right here. We were reviewing the algebra, the conversion between exponent and radicals. We went over these exponential formulas and the relationship between exponent and radicals. And we convert all of this into the from the radical to the exponent. So basically that's exactly what we did, right? I also mentioned to everyone that because you need the exponent to work with in order to differentiate. And if you integrate, then that means you have to get that into the exponential form as well. Okay, so for unit 1, we will learn the differentiation, but the last unit of the course we will learn how to integrate. So now I hope everyone realized the purpose of working on this exercise. Alright, so I went over quite a few questions for everyone here, and I want to draw your attention to this type of question that we have done. Okay, so right here what we have is we want to simplify, okay, and then we write to certain exponent. So what we have done is we write it in this form, and we also write it in this form as well. We simplify to whatever we can. Okay, we simplify whatever we can until we have a very simplified version of this particular function with x raised to an exponent. Alright, okay. So let's get back to our lesson. Okay. So for my example, I would like you to recognize that whatever you can, you go back to the very basic rule and also apply the basic rule, also apply the function raised to a power. You work with product and quotient rule only when you have to, and I will explain all that with everyone in the further into the lesson or maybe the next lesson. Okay, so let's take a look at example number 1. I want to show everyone to analyze your function first, analyze it first, and then in the process of analyzing the question, you will find a clue to, or you find the key in order to continue on. Like you probably find the correct formulas of derivative to work with in this case. Okay, so now you see 5x squared divided by 7x in exponent 5. I'm going to ask everyone to take a look at the formula that I provide for everyone. Excuse me, I just want to take a sip of tea. Okay, thank you. So what we have is you have a basic rule, you have derivative of constant, right? And you have the chain rule, and you have the product rule, and you have a quotient rule. So in this quotient rule, quotient means you divide it by something, and product means that you multiply by something. So if you compare question number 1 with one of these formulas above, you probably tend to say, okay, I'm going to use a quotient rule because I have two functions divided by each other. But do we need to apply quotient rule in this one? No, we don't. Okay, go back to the review that I have shown everyone to work with. So in this question right here, what you have done is you simplify your expression to a very just one x raised to an exponent, because you can apply the exponential rule in order to get to this point. So you can try to work with this question by simplifying it first before you apply any derivative rule to it. So what I will do is I will simplify this by, I still write y. Okay, you write y prime or you write dy over dx only when you start applying the differentiation. So what I do is I will take 2 minus 5, okay? Because I am using the formulas am divided by an. So what I do is I will subtract the 2 exponent, okay? Because I have the same base here. I have the same base as x. So I have 2 minus 5. So in this case, I will have 5 over 7 x raised to exponent minus 3. Right? Okay. So after you get this, then you are going to see what type of formulas that you want to use in this case. So it's actually very simple. Now let's go back to the basic rule of derivative, which you would take the exponent multiplied by the coefficient in front of x. At the same time, you take 1 away from the exponent. Okay, so now, because you start to differentiate, so you are going to write dy over dx in this case. So that means I will take this multiplied by minus 3. At the same time, I will take 1 away from the exponent. So in this case, my answer should be negative 15 over 7 x to the exponent negative 4. However, the question asked me to express as positive exponent, so I should write this as negative 15 over 7 times x to the exponent 4. Okay, so as simple as that. It looks a bit complicated, but once you analyze your expression, you know that you can combine the x squared and the x to the exponent 5, then you can just simply apply the basic rule of derivatives. Okay, so question number 2 is the same. You are going to simplify this expression as well, and then you can just apply the basic rule of derivative. So y equal to 7 over 3, I will have x raised to exponent 1 and subtract a half. Okay, because square root of x is x to the exponent a half, and you just subtract the 2 exponent. So 7 over 3, this will be x raised to exponent a half. And then the next step is to write dy over dx. So you take 7 over 3, you multiply by the exponent. Immediately after this, you take 1 away from the exponent, and then we just simplify. So we will have 7 over 6 times x raised to exponent negative half. So I have to write it as positive exponent. So I should write 7 over 6 times x to the exponent a half. Alright, very simple, is that right? Okay, so far we don't have to apply the quotient rule. We just simplify our expression, apply very simple formulas for the exponent. Then we can simplify our expression to just a coefficient x raised to a power, and then we apply the basic rule of derivative, and then there we got our answer. Alright, so when it comes to question number 3, okay, so that means you are going to apply this rule. So I'm going to ask everyone that you are going to apply this rule right here. Okay, so this is the rule that you are going to apply, because you are having the sums and difference of quite a few functions. So when you differentiate, you can differentiate each one individually. Okay, so let's get back to our lesson. And what I will do is I will differentiate each one individually, right? So I will take derivative of 8. I add that with derivative of 7 times x to the exponent 6 divided by x to the exponent 3. But I know that I can simplify this expression before I can differentiate. Okay, so what I will do is I still write y because I haven't applied the derivative rule yet. So I will have a plus 7x to the exponent 3, right? Because x to the 6 divided by x to the 3 is x to the 6 minus 3, so I should have x to the exponent 3. And from this one, I will write it as 3 over 5 times x raised to the exponent negative 1/3. Okay, because cube root of x is 1/3, and you bring it up to the numerator, become negative 1/3. Okay, so now what we are going to do next is I will differentiate each one individually. So basically, I will write it as dy over dx is equal to derivative of 8 as the function of x plus derivative of 7x to the exponent 3 as a function of x, subtract the derivative of 3 over 5x to the negative 1/3 as a function of x. So basically that's what I have to write. And most of the time you see that I will skip this step because we know that we differentiate each term individually. Okay? So now dy over dx, what is derivative of a constant? We learned earlier in our formula, the derivative of a constant is equal to 0. So let's go back to our formulas. So this is the formulas right here that we are going to use. Derivative of a constant is equal to 0. And we are applying these formulas right now. Excuse me. So I will write 0. And the next step is to take the exponent times 7. So I should have 21, right? So 21 x squared, because I take 1 away from the exponent. So the next one is to take negative 1/3 times 3 over 5. So let's write that step by step. So x is negative 1/3 minus 1. So then dy over dx is equal to 21x squared plus, so I know that and that cancel out. I should have positive 1 over 5. And x raised to the exponent 4/3 negative. Okay, and the next step is to write this as positive exponent as required. Okay, there it is. So it's very simple. So let's continue with the next question, because I believe I still have a lot of time. So, alright, so for number 4. So this one we have to be careful here. Okay, so I have a function 2x squared plus 5, all of it raised to exponent 4. So in this case, I have a function raised to a power, and it's a power of 4. So this binomial raised to this exponent 4 is not easy for us to expand. Okay, so don't try to expand this and get it into the simplified version of this expansion of this binomial, because it's actually very complicated. I would recommend everyone that if you have a function raised to a power, then apply this chain rule. Okay, so here's the chain rule. So this one is the chain rule that I'm talking about. So you are going to let u equal to that function. You differentiate that function u, and then you multiply by the derivative of what inside the brackets. Okay, so let's get back to our example. And in this case, what I have is I will apply the chain rule. So I will write it here, chain rule. So dy over dx is equal to 4 times 3x squared plus 5. At the same time, I will take 1 away from the exponent, and I also multiply by derivative of what inside the brackets, right? So I will take 2 times 3x 2 minus 1. Okay, so in this case, I should have 4 times 3x squared plus 5, all of it raised to the exponent 3, and this should be multiplied by 6x. Okay, 2 times 3 is 6, and 2 minus 1 is 1. So in the end, I just have to simplify my answer by writing it as 24x multiplied by 3x squared plus 5, all of it raised to exponent 3. Okay, so that is our chain rule. Okay, for number 5, so do we need to use a quotient rule in this case? No, we don't. Okay, you have negative 2 divided by this expression. Because you just have a minus 2 as a numerator, it's very simple just to convert this denominator into a numerator. So you can write it as negative 2 times 5x minus 2, all of it raised to the exponent negative 1/3. Okay, so let me write a step here for you. This will be 5x minus 2 to the 1/3. Okay, and then I bring it to the top, I make that into negative 1/3. So all I have to do now is just apply the chain rule. Okay, so the chain rule, dy over dx. Don't forget to write dy over dx because you are telling the reader that you are going to differentiate here. Okay, so negative 2 times negative 1/3 of 5x minus 2. I will take 1 away from this exponent, and then at the same time I would take derivative of what inside the bracket. Derivative of 5x, is that equal to 5, right? Because it's here 5, and derivative of a constant is equal to 0. So I can explain this. Okay, derivative of 5x, I can write this as derivative of 5 times x to the exponent 1. Okay, so now what you have is you are taking 1 times 5, so that is 5, and 1 minus 1 is 0. So that means 5 times x to the exponent 0. Anything to the exponent 0 is 1. So in this case, you just have 5. Okay, or you can think it like this. 5x is minus 2 is a straight line. So what is the slope of this line? It's just 5. So the derivative of this line is actually equal to 5 here, right? To get the slope. So the next step is to simplify our answer. So I should have 10 over 3 as positive. Okay, and 5x minus 2 raised to the exponent negative 1/3. But I have to write this as a positive exponent, so I can write 10 over 3 times 5x minus 2 raised to the exponent positive 1/3. Okay, so this is to explain to everyone why 5x derivative is equal to 5. Okay, so and then we are good here. Alright, so let's continue with question number 7. Okay, I mean question number 6. So again, this one is very much similar to question number 5. I have to apply the chain rule, but before I do that, I need to convert this to the exponent. So in this case, the exponent should be equal to negative 2 over 3. Okay, so that's why I am asking everyone in previous lesson that you should work with the conversion between the exponent and the radical to exponent, because without doing this step correct, all the process that we try to do here or we try to differentiate, they were all wrong because we have the wrong exponent. So this step is actually quite crucial in working with the derivative. So now dy over dx will be equal to minus 2. I take exponent multiplied by this, coefficient negative 2. Immediately after, I take 1 away from the exponent. Okay, so take 1 away from the exponent. Then the step after is to multiply by derivative of what inside the bracket. So negative 2 over 3 minus 1. And derivative of what inside the bracket would be 7. Okay, so what do we have now? We are having 2 times 2, 4 times 7, 28, negative, negative, so make it a positive, so 28 over 3. And 7x minus 3 raised to exponent 2 over 3 minus 1, I should have negative 5 over 3 in this case. So write this as positive exponent. I should have it as 28 over 3 times 7x minus 3, all of it raised to the exponent 5 over 3. Alright, so what I'm going to do is I'm going to leave the product rule and the quotient rule for our next video. But before I say goodbye to everyone in this video, I would like to go back and to the very beginning of this handout and would like to emphasize a few points for everyone. Excuse me. As you know, I want to approach derivative rule in a very simple way. I really don't want everyone to worry about the other notation, which is the fx. Okay, so indicating fx and indicating the definition of derivative in terms of their limits is actually quite complicated, and we took them all out from the course, and therefore approaching derivative is as a rule is actually very simple and using this type of formulas. So the basic rule for derivative is you just take the exponent of your function x, multiply by the coefficient, and at the same time you take 1 away from the exponent. So multiply and then take 1 away. Okay, so that's the process of derivative. It's like an operation in calculus. That's the rule that we have to follow. So in order for us to take the exponent and multiply, we have to convert everything into exponent. And if we have derivative of constant, it's always equal to 0. Just like thinking of derivative of a line tangent, actually not the line tangent, but the a line parallel to the x-axis in this case. Okay, so you have this is y, this is x. So let's say y is equal to 5 in this case. Okay, so given this straight line right here, if you have to give me the slope for this, you can tell me that the slope is equal to 0, right? So the slope is equal to 0 in this case. If you have like a line perpendicular to the x-axis, in that case you have no slope. Okay, so this horizontal line here, you can say that the slope is equal to 0. Okay, so if you have a function raised to a power, this basic rule still apply to that power, but you must apply the concept called chain rule. So after you take derivative of that function, you have to multiply by derivative of what inside the bracket. That means the derivative of your u right here. Okay, derivative of sum and difference. Then you can differentiate each one individually and you add or subtract them. In terms of the product rule, with the product rule, if you have two functions that multiply with each other, then you have to apply the product rule. Okay, if you cannot simplify your function any further, then the product rule will have to apply in this case. So quotient rule, when you have two functions that divide into each other and you cannot simplify them, so then you must apply the quotient rule. And for some questions that I have gone over with everyone, the question number 1, we don't need to use a quotient rule. The reason for that is you can simply simplify this to exponent x squared and x to the exponent 5. Simplify this to this expression, and then you can just apply the basic rule. Okay, the same thing here. Basic rule for derivative. You don't need to make it any more complicated than applying the quotient rule in this case. And the same thing here, you simplify, but you have to differentiate each one individually. Alright, so whenever you have like a function raised to a power like this, don't try to expand the expression, but just simply apply the chain rule in this case. Okay, even you have a quotient here, don't apply the quotient rule because you don't have the x attached to this, the -2. So you can just simply change that into an exponent and then go from there. Alright everyone, thank you.